we didn't have any materials.
You don't have any material.
No, I didn't have any materials in my exam. That's why I didn't send them to you to prepare for our preparation. But okay, give me a second. Maybe I can find them in our
Okay, thanks.
classes. Okay. 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 Oh, and I wanted to ask you, can I have more lessons from you? Like, and so can you send me your timetable for this week?
You want my schedule
Yeah, I want your schedule.
to do more classes with me?
Yeah, do more
Okay,
classes with me.
I will send to you, but I have a problem to send now because I have a lot of students want do class with me. So after our class,
Yeah, sure.
yeah, I will send now. I send now because more
Yeah, of
problems, but
course.
more money.
Yeah, no
I
problem.
will send to you just a second. Uh,
Yeah.
let me see. Okay, it's here. Use Lagrange multipliers to prove that the triangle with maximum area that has a given perimeter be equilateral. Okay, that's not so impossible to do. Let me see. Let me see. Because Lagrange multipliers is that method we already studied in our class where you put a new variable in your strategy, in your function. So here we have, we want maximize that a formula, that this formula here, but we can think a little bit more in this case because we have, we need prove something. We need to prove that triangle with maximum area that has a given perimeter P equilateral. And we know we have a formula to perimeters. It's involved their own formula. This is here. And we know the we have something here. This S here. This S is the same perimeter. Same perimeter is the half of the perimeter. Okay, yeah, this is
Okay.
right here. Okay, so we know something. If we have a triangle, the sides of our triangle is x, y, and z. We know P equals x plus y plus z, right?
Yep.
So we can take our restriction in this equation here because um, we can. This is our restriction because this is the
Okay.
sides of our triangle. So we need to use this in your problem. Okay. We can simplify some a little bit this equation because if we maximize this, is the same thing we maximize the square of this. Okay, it's very easier work with the square root thing. Okay, so our function is this one. And another thing, for example, this is a constant, right? This is a constant. So when we want maximize something, we cannot, we don't need use the constants that multiply all the variables, okay? So the easiest way to maximize this is, just a second, s minus x, s minus y, and s minus z. This is the easiest way to maximize this equation, right?
Yep.
So we have the restriction and we have the function. So we can use the theory of the Lagrangian multipliers. I will do something a little different. I already did in our another classes. I will think about this in terms of gradient. Okay. For example, we
Okay.
have this gradient uh, our of our function. These partial derivatives you can do for me. And we need to do the gradient of our restriction too. But this gradient is very easy because it's just derivatives of partial derivatives of any case here. So will be this vector, right?
Yep.
And in the theory of Lagrangian, using gradients, we can equalize the things. Lagrangian multiplier, gradient. Okay? So
Yep.
to start our problem, you need to do the partial derivatives of this thing here. So when you have these partial derivatives, you can send to me. Okay?
Okay.
Okay,
Let's do this.
let's go. When you when you finish it, just send me, okay?
Yeah, I send it to you.
Okay. I will
No, I already sent it.
I will take a look just a second.
Yeah.
Okay, you did. So we can rewrite the things because we have the gradient now. So our gradient is um let me see. I can write all the things. So now we can equalize the pairs, okay? Because all the pairs is equal lambda. So this is a easy math now. Easy math, easy um, things to do. Oh my god. Um,
Yeah,
we
things.
can equalize the things because all the things is equal lambda, right?
Yeah.
So doing this with the three equations in a lot of alternatives, you can obtain the value or better the relation between x, y, and z. Okay, but I
Okay.
cannot do this for you. You need use your knowing your know-how in math to obtain this relation. Okay, but it's very
Okay.
easy. You can do first this, and after you can do this, and after you can be these two things together and obtain the
Yeah.
things, right?
Okay.
Uh,
Okay. Let me see. Yeah. Okay. Mm.
Uh, are you okay here? This
Yeah, I'm
question?
okay. Yeah,
Okay,
yeah.
okay. Amazing. I need to go to bathroom. Just a
Yeah,
second,
sure.
okay?
Yeah, yeah.
Oh, you already did. Let me see.
Yeah.
Let me see. Let me see. Let me see. Okay, you obtain a cool relationship. Very cool. The relationship is a pattern in these maximizations problems. Okay,
Yeah.
is usually we have this um, answer here. Okay, so okay, we have
Yeah.
this for our constraint, for our um, this thing here. I don't remember the name in English. Restriction.
Yeah.
So okay, this is the answer. Amazing, very easy, very cool. Okay, let's go for the next one.
Good. Yeah.
Okay. Let me see. Uh, okay, use Lagrange multipliers to give alternative solution, indicating. I don't know what exercise is this, but you can send me. I don't know. Let me see. Indicate exercise in section 14.7.
Mm, I think it is, yeah, it is this one. So it is 40, number 42. It is all about
Oh,
40.
okay.
Because my teacher, he took these exercises to his file from different books, different math books.
Yeah.
So yeah, that,
Okay. Let me see. Uh, let me see. Let me try something here. We need to use Lagrange multipliers again. But what you need to minimize here? We need to minimize the distance, right?
yeah,
Between a generic point and this point here. Okay? A generic
yeah,
point of this plane, right? So we need use that equation, the distance equation. We need to use the distance equation here. Okay, the distance equation I know you know, but I will using a easiest way. Okay, without the square root,
okay,
because it's more is easier for us. We can simplify a little more. I think it's enough for now. This is our objective function, okay? But we have our constraint function too. The constraint function is the equation of the plane because our x, y, and z need to be a point of the plane, okay?
okay.
Amazing. So I think you know what you need to do here, okay? I suppose you like it the another way, the gradient way, because it's more easier,
Mm,
it's more cute, it's more smaller. In Brazil, we have in Portuguese, we using more smaller uh, than more small than smaller. Is a Portuguese thing. So because this I ever wrong my English, but I know Russian and Portuguese is syllabic languages. So when a person who does understand Russian or Portuguese, when this person listen something speaking Russian Portuguese, this person thinks is very similar because our languages are very syllabic, different,
yeah.
for example, of English or Germany. You do you know this?
Yeah, a little bit. I heard about it.
Is very similar.
Yeah.
So okay, but of course, Russian is very hard. It's harder than Portuguese. But okay, you can try. Okay, You can
Yeah.
try do this, very easy for you. When you finish, is very similar. That's another question, okay? So when you finish, you send me something, okay?
Yeah. Okay. Okay, let's. Professor, yeah,
Say.
can you hear me? Yeah, uh, I understand how to do it, but like I know what I should do next, but can we go to the next task because I want to do I want to finish this one at home and now like to try to do more tasks
I
now.
suppose this is this is fast to answer, man. Let me see what you
Alright.
did. Let me see what
Yeah,
you did,
sure.
please. Because all the derivatives is easy. I already did
Ah,
this problem. I can send to you. I can do in a minute for you, but first I want to see what you
something
do.
wrong. Yeah. Okay, so I sent you how I did like the gradient, the function. Now the gradient of m, but the problem is
Okay, let me see. You did the partial derivatives, okay, but
yeah, of both. Yeah,
this is very easy, man. This is very easy
yeah,
because
and when I put them to, I'm not sure. Can you check if I put them correctly in Lagrange matrix? Here it is.
it's not a matrix. It's just
Not
vector, right? So now you can put the derivation of the constraint. So we have
something
2x,
like this.
2y minus 1, 2z, z minus 1 in the parentheses. Okay? I don't know if in English is parentheses, but you understand.
It is.
So here we have the lambda, and the derivation of this is very easy. 1 minus 2, 3.
Yeah, I sent. Check the WhatsApp, please. I sent how I apply this to.
Okay, you send me. Okay, okay. This is cool. You
Yeah.
already did. You
Um,
already did. Uh, now,
I just don't get what is our next step. How we
now
should.
we need using the multipliers, the Lagrangian multipliers, to equalize the equations. Okay.
Oh,
For example, the first equation we already have the Lagrangian isolate. The another one
yeah.
we have this. The another one this. Right?
Yeah.
Now you can equalize everything.
Oh,
And you again can do the algebra to obtain a relationship between x and y and z. Again, this will be something proportional. X will be proportional to y and proportional to z. Okay. And the another question was equal, but now I suppose it will be proportional. Okay. But it's very easy. It's like the another question, right?
yeah.
So you need to remember Lagrangian multipliers is is to need to is necessary to equalize the equations. Okay, we using the Lagrangian multiplier to equalize the equations. Okay, just for that, just for that, we use this thing. Okay, so now we
Okay.
have the equations equalized, and we just need obtain a relationship. Okay. But this is very easy. Let's go to the next one. Oh my God, Kobe Douglas model is is a is a trash. I hate this thing. Hate this thing because this is very hard, and this is not about my formation in math. But I already work a lot of times with Kobe Douglas model, so I know how to do this probably. The total production P of a certain product depends on the amount L of labor used in the capital in section. And now we discuss how the Cobb-Douglas model follows from certain economics assumptions where B and alpha are positive constants, alphas less than 1. If the cost of a unit of labor is M, a unit of labor is M, and the cost of a unit of capital is N, and the company can spend only P dollars as its total budget, then maximize the production P. Okay, we need to maximize the things again, right? So we need write an equation to do this. And our equation in this situation is very easy because we have the constraint here, right? And we have the Cobb-Douglas to be our function to um, optimize, okay? So we just need to put these things all together. So our Lagrangian will be a Lagrange of L, K, and lambda, B, L, alpha, K, 1 minus alpha minus lambda, ML plus NK minus P, right? Again, you
Right.
need to do the derivatives in these variables, right? So I will do this for you, okay? Because
Okay.
very easy,
Yes, please.
but you need to be more. You need to be faster doing this,
Yeah.
okay? But
Yeah.
only, you need to only try more.
Yeah.
Alpha L, alpha minus 1, because now we have these generic terms. Is very boring. Equals 0, L, K, B, 1 minus alpha, L alpha, K minus alpha, lambda n equals 0. Man, I really want to ask you a thing, but I don't know if you is comfortable to answer me.
Yeah. Sure.
I lived in Portugal in 1 year ago, 2 years ago. I live in Braga, a city in the north of the Portugal, and
Okay.
that in that place, the people really love the Ukraine things, like have a lot of flags and have a lot of Ukrainian girls. So you don't have any problem because you are Russian, right?
Yes, I am, but I don't think it is a problem anymore. Now people has Israel to speak about, and it is not so popular anymore. Like the main, and now also as Russian as Ukrainian people, we both hope for. We don't believe, but we hope that there are going to be peace between our countries, because now it is not communication, but meeting. I don't remember where exactly, or in Turkey, it doesn't matter. So, yeah, so about the main question, it is not a problem at all, because we have a lot of great people. I have some in
I
a
understand.
university, and we don't have any problem with it. Like,
The-
even if we don't like each other, uh, some of us, we all are very, we're students. We don't have
You
a
don't
right
have
to
time to
affect.
think in that
Yeah, we don't have time about to
dumb
think about.
fights. Yeah, it's very sad.
Yeah, we fight with logarithm. We fight with formulas.
Derivatives.
Yeah,
Yeah,
we don't have
amazing,
time to
amazing,
fight with people.
amazing answer.
Yeah.
Okay, so I already did the derivation for you. So now we have two things with Lagrangian. So again, you can isolate the Lagrangian and equalize these things to obtain some relationship. But in that situation, um, you you need an equation where you have a relationship between L and K. For example, something like you need get something like L equals or L proportional to K. Do you understand? You need
Yeah.
something like L proportional to K. So you need using that three equations to obtain this proportionality. Okay, using of course alpha and n and m. Okay, so Probably your equation will be something like L equals something like, okay? Something like L equals alpha, M, something like that. But K here doing the proportionality, okay?
Yeah.
So I really need you to do this for me, okay?
Okay. The
We try.
proportional. Okay. That's true.
All the things start when you equalize the uh, lambdas, okay? You
Mhm.
also you need to put lambda equals something here, lambda equals something here, and equalize the things, okay?
Okay. Okay, probably it is like that. I'm really sorry. Takes so much time.
Send me, please. You
Yeah, I
already
said,
sent me.
yeah,
Okay, you. I don't understand because you just copy the things, but what? Where is the
oh,
manipulation?
yes, sorry, I sent you the wrong part. The wrong part. Oops. Yeah, here is the manipulation.
Let me see. Um, Okay, seems interesting, but I suppose the manipulation can be improved
Which way?
because I don't know. Let me see. Where is the answer? Where is
There is
L
no.
equals something? I don't see anything.
M divide it equals M divided 10. What do you mean? Where is answer?
Because I need L equals something, right? And
Yeah.
I don't see anything. But you, I don't know, do something here,
Yeah.
simplify. Uh, I need a better photo too. Strange, man.
Yeah.
But I can do this for you. But you
Yeah.
need to
Those.
understand something. You need to understand something. The
Yeah. Really.
derivatives is easy to do. The derivatives is easy. It's just the potential rule, product rule, easy
Yeah.
things, right?
Yeah.
What is very hard here is the algebraic manipulations, like this, okay, like this one.
Yeah.
So we need have attention, a lot of attention in these manipulations. Um, Here you did something interesting. So I will accept your simplification and I will copy. I already did the I already did this problem, okay? But I will
Okay. Yeah.
do the things what you did. So now I need L proportional to K. So L in your terms will be alpha 1 minus alpha n over m k, right?
Yeah.
I suppose this. But this is very strange. This is very strange to me because
Why?
where is the p, right? We have p.
Ah.
So in some
Yeah.
place we need
Okay.
put p in some place. I don't know if this simplification is right too, but to me it
No, I
seems
just
good.
I
Seems very
just
good.
thought that the somewhere.
But where is the p? Because I did this question using p.
Yeah.
But this is right to me too. But I use p here in some place. Where I put this p? Uh,
I used to put the.
I suppose,
I have
and
no
I
idea
suppose in
where.
some place I take this one I show to you. I think it's similar to your thing, right? It's the same thing. Okay.
Yeah.
So here I put P after this step.
Okay.
Okay. Because we know this, right?
Yeah.
ML plus NK equals P. So if I don't have more space to do this here, I need more space. I will copy this expression and start a new page. Just save here, just a second, okay. Now I take this and we know another thing, ML plus NK equals P, okay. So
Yeah.
we can substitute, we can do a substitution here. What
Yeah.
you already did what I asked to you. Amazing, you are right. Okay, but now we need improve our answer using P because our question say this to us, right? Let me see. Show that maximum productions occur. Okay, we need these
Okay.
answers, and the answers have P. So we need to do this substitution. Okay, so but it's not hard for us. It's very easy because we just need do. Let me see. Okay, what we need to do. For example, we can put this m again, multiplying b lm, right?
Yeah.
Uh, just let me see. Let me see. Let me see. For example, uh, here we have L. Okay, but if I multiply this answer for M, we have in the place of L, I will put all these things. Okay?
Okay.
Are you understand me? Because I will
Yeah, I think so.
write this equation, right?
Yeah.
So in the place of L, I put this. This is here.
Okay.
Okay?
Yeah.
So we have a simplification here. And we can simplify a little more. And we get something like NQ and key alpha 1 minus alpha plus 1p. So we need to simplify a little more. Isolin k. Isolin k is very easy here. It's just put the things down. And anyway, you know. You know to do, but you sometimes is lonely. So we have this expression for k after some simplification, right? And we already know L is right in terms of k. So in the place of k, I will put this term here. I will erase this and copy this and put here. Okay.
Okay.
So we can simplify this term too. And we can rewrite this. Will be 1 minus alpha p. If we can cut this two, right?
Yeah.
So these alphas erase, sorry. And here m. Okay. You already get the answer. What the problem say to us? Let me see. I am not sure, but I think is the things. Right? Let me see.
Yeah.
Here's the m. The L, sorry. Same L, and my K is the same thing. Amazing. So we get the thing, right?
Yeah.
And we need to note this is easy, man. This is very easy. But I did all for you. I did the derivatives, and you did this for me. This was cool. This was cool. But you need isolate the L, right? You
Yeah.
don't isolate the L. But okay, it's enough for us in that case because we need a substituting earlier in terms of P, and I did this and obtained the equations. Okay, so
Yeah.
again, what is the most important to you is do the algebraic manipulations. It's not the derivatives, because the derivatives is very easy. All the derivatives is easy here. It's just potential rule, product rule, right? So
Right.
you need focus in the manipulation. Okay?
Okay. Yeah.
Okay, man. Amazing. I think you are good to do the things
Yeah.
alone without me. But
Definitely.
if you want more classes, I sent to you my schedule. My schedule is
Yeah.
here.
Thank you. I
So
will
you
think
think
about it.
about your time too and send me some message, okay?
Yeah. Okay. Thank you very much. Yeah.
I appreciate you. Bye bye.
Yeah. Goodbye.